Okay. I don't know if anyone's here now. Sorry about that. So I think I'm on higher res now. Cool. So I stopped and started again. So I'm sorry. I think I might have lost the one person who asked me that question. So I'm sorry about that. I will post that back on to. I'm just going to repost that link in case anyone follows it. Delete that one and to say streaming here on YouTube. Hey, cool, brilliant. Thanks for letting me know. I think that's super helpful. But sorry for if I kicking you out and get you back in again. But yeah, cool, awesome. I'm glad it's super crisp. That's super helpful. Right. Okay. So where are we up to? So we've got does create an executable with build, but the key thing it said was that any executable that any library that you use that is not any Python libraries used are not including the executable binary, so they have to be provided for the environment. So that's worth knowing. Alrighty. So let's create some variables. So let's extend our basic program by prompting the user for their name and including it. Okay, so exactly what you would do when you're kind of learning any kind of language. Okay, so let's do this. So we're going to use a var keyword. So it feels very JavaScript ES6, but we're also going to type it like TypeScript. Interesting, but also like in Python type hinting as well. So who are you? Fine, and then we'll create a greeting and we'll say, so we're going to interpolate hello name with exclamation mark, and then we're going to print the greeting. Okay, print greeting. So interesting that we need, this is the shell, so we should be able to run life Mojo. Here you are, I'm Kevin. Hello Kevin. Okay, that's nice. I'll put a space in there just for that. All right, so that feels normal and helpful and about right. Okay, however, implicitly declared variables still have a fixed type which Mojo automatically infers. Okay, so like TypeScript, it's got a really decent type inference system, so I'm assuming if I don't type this here, then this is going to be typed still as a string down here. Okay, so we're getting exactly the type of stuff we'd expect from a typed language which has a decent inference system. That's cool. And I presume I would get some, if I try to reassign greeting to a number down here, it's going to shout at me. Ooh. Red line here. Oh, you got inconsistent indentation. That's got tabs. And that's got spaces. Sorry. And this is the error I was hoping for. It's saying cannot implicitly convert int literal to there. Okay. Can I explicitly? So if I change this to, they call that an int literal apparently. If I change this to an int literal, am I allowed to do that? What's it say here? String is unused. So do I have to read? Okay, I don't know. But type inference is great. We like type inference. It means that we don't have to type all the time. We can use the inference system and trust it. So that's pretty cool. We can learn more about variables in the variables section in the manual. Okay, well, if we need to, we'll do that. But sounds like, let's see, so var implicitly, okay, so again, I guess you can do, var count implicitly, and we try to convert it, shouts at you, seems good. Explicitly defined variables, all right, type annotations, late initialization. Okay. There's other bits here. We can think about scoping and other bits. All right. So it seems pretty self-explanatory, or so it doesn't seem that different from other things that we might see. Okay. So let's have a look at Mojo's int and list. So types represent the game state. As originally envisioned by John Conway. So remember, we're looking at Conway's game of life. The world is an infinite two-dimensional grid of squares, but our implementation will constrain the grid to a finite size. Drawback to making the edges of a grid hard boundaries or fewer neighboring shells around the edges. So we'll module as a toroid, a donut shape where the top row is adjacent to the bottom row. Beautiful, love it. And the left is adjacent to the right. A toroid. Interesting. Torus. Cuboid. Yeah, okay. To keep track of the height and width, we'll create an int and a word and assign integer of the word size of the CPU. I've never heard that word before. A word is the natural unit of data per particular processor. Never heard that phrase before. That's interesting. To represent the state of an individual cell, we'll represent the cell state with an int value of 1 for populating 0. Okay, seems fair. And to represent the state of the entire grid, collection type, and we use list. Alrighty. I feel very Python-y. I feel like I can see that. So I've got a row, which is going to be a list of ints. But interesting, I've got these rounded brackets or these parentheses to instantiate it. And then equally names is a list of strings. Now I think this can't be defined outside of a function to do expressions or not yet exported at the file scope level. Okay, so this has to happen inside the main file. And it's going to shout at me because I used a tab instead of a space. I need to get my okay, so here we've got a list of integers, and here we've got a list of strings. I think it's complaining. If I hold up the problems tab, we can see, yeah, it's complaining because they're unused variables. So that's okay. We can also create a list with an initial set of values. Fine, and we can append with .append. We can find out the length. We can pop. So all of the operations we'd expect from Python are available here. That makes sense. We can also nest lists, so lists inside of lists. That seems great. Awesome. Oh, yuck. Okay, right. So now we're going to get started and actually create our grid. So we say we've got number of rows, we'll set to be 8. And again, we're not typing that because it's being implicitly inferred by the type inference system from the initialization value. And we say the glider is list. So the glider, this is an interesting shape here. It goes 1, 1, 1, 1, 1. And you can kind of imagine what happens is that this cell dies on the next iteration. But this cell survives because it has 2 neighbors. And this cell dies on the next iteration, but this cell survives. So these 2 survive, and some more of them get reproduced. And so what happens is over time, this glider moves from left along this diagonal as it moves down. I'm just going to copy and paste this rather than trying to. Or is that going to be spacing? No. Why are you moaning? Ah, yeah, it is spacing. Who's shouting? Why are you shouting? Leading indentation uses inconsistent white space. That's all white space. So it should be 1 level less. That's annoying. Okay, what I'm going to do for now is just going to copy the whole thing because I assume it's consistent within itself. Cool. Okay, so we've got a list and a list of lists. So we've got this nest of lists. So now we want to create a function that's going to print the grid. Okay. So let's add the following definition and we'll call it grid to string. Okay. So what's going to happen here? Let's see. So we'll create a grid string, which is going to take the rows, which will be an int, the columns, which will be an int, and the grid, which will be a list of lists of ints. And is it going to return a string? Yeah. So that's the same typing that Python allows us to do if we want to. So we've got that sort of same optional typing that's going on there. Okay, so what I'm going to do, I'm going to create a string. So I'll initialize an empty string. For row in range rows, again, very Python-esque, and for call in range calls. Right, you're shouting at me. Oh, I'm getting so annoyed with this. I'm going to make everything in this function tab based, and then I can fix. You can fix this in your configuration for, but I have a fix for Python. And obviously this is the first time I've worked with Mojo, so I don't have anything set for this here. So if it's a 0, we're going to make it a star. because there's nothing, or if it's one star, we're going to make it a star because it's populated. Otherwise, we'll make it an empty string. And then if for row and row, if row does not equal rows -1, so if row does not equal rows -1, oops, so if it's not the last row, then we should append a new line character. And we've done all that. We should return the string. You should be in, yeah, at that level. Okay, I saved it and it's just changed all the space. It's changed all the spaces. Ugh, okay. And I think that's from, I think I'm using, what am I using? Like, Black. I think Black might be doing that, which is a Python formatter. But we'll see what's going on. When we pass a value to a Mojo function, default behavior is the argument is treated as read-only reference to the value. Go like that. However, the Mojo compiler determines that there's code in the function that can change the value. The argument gets a copy of the original. We see there in specified location. So this, I think I saw somewhere about borrowing before, which made me think about Rust and its way to be able to handle that kind of safety. I think that's similarly what's going on here. See there, we can specify different behavior. Okay, fine. In the body of the function, we generate a string by appending. Yeah, we did all that. We're looping over, describing the for statement, elements of the list directly. So for, okay, so well, that's, and again, that's very similar to Python. Now that we've defined our grid string, let's invoke it from main. Okay, so we'll say that result equals grid string of num rows, num calls, and glider, and then we're going to print the result. It's going to kill me. Right. Use unknown declaration of calls here. For call in calls, just because it had a D there. Let's fix that. No problems. Fantastic. So let's run it. Let's save it and run it. We hopefully should see our little glider. What's happened there? I see. We need to bring that up one level. So we're adding a new line after every character instead of after every loop of every column loop. Right, I think that should fix that problem. Okay, cool. So we've got our little glider going on there. And that's okay. Now I want to create a module and define a custom type. Ooh, that sounds exciting. We're currently passing 3 arguments to this to describe the size and state of the grid to print. A better approach would be to define our own custom type and encapsulates all that information. I agree. A Mojo struct is a custom type consisting of fields and methods. Fields are variables and methods are functions. Fine. So we're going to create a grid version 1.mojo. We're going to annotate it with value and declare it as a struct called grid, which has rows, which is going to be an int, calls, which is going to be an int, that should say rows with an S, and data, which is going to be list of ints. Okay, makes sense. Mojo requires you to declare all the fields in the struct definition. You can't add fields dynamically at runtime. You must declare a type for each field, but you cannot assign a value as part of the field declaration. Instead, the constructor is responsible for initializing the value of all fields, which is okay. Mojo supports structs of several different lifecycle methods. When it's created, moved, copied, and destroyed. Fine. The value decorator to your structs automatically generates the lifecycle methods for you. Because we've used the value decorator, grid includes a member-wise constructor. The constructor arguments are the same names and types that are there. Fantastic. It's also in the same order. Oh, cool. Okay. So when we initialize it, we can use that ready to go. Okay, cool. That kind of makes sense. So let's use it. So at the top of our file here, we'll say from grid version 1 import grid. And then we'll say grid string takes a grid of type grid and returns a string. And so this now should be grid.rows, grid.calls. Oh, it's actually grid, yeah, and then down, and then this should be grid.data of row and color, I imagine. Yeah, cool. So then, oh, this should be, if not grid.rows minus 1. Okay, cool. Yeah, that looks good. Yeah. So then if we refactor this, instead of defining the number of rows and number of columns as separate variables now, we'll define it in a constructor for our grid. So we'll say that our starting grid is going to be a grid of size 8, 8, and we'll also have initial data of glider, and then we'll pass our starting grid here, and we'll print our result. So it should hopefully do exactly the same thing. Brilliant. So we've refactored. It looks a bit nicer now. We can see the initial shape. If you squint at it a little bit, you can see the initial shape. But that's looking okay. All right. So we want to implement the grid string as a method. Okay. So, all right. So I'll go back to over here. And I will 1, 2, 3, 4. I'll define inside of here a grid. So this feels a bit, this struct is feeling a bit like a class syntax from Python, and using self inside it kind of makes a bit of sense. And then we're going to say the string, lots of the same behavior. So we'll say for row, self.data row, it sounds about right. Why are you red squiggly? Expect a return. Ah, of course you did. So we want to return string there. Why are you red? Ah, indentation, of course. All right, let's fix that. Want to be there. Cool. So it's now, we're using that grid to be able to encapsulate it. So now if we go back over to our Mojo, we can get rid of this over here. And then we're saying, we're printing start dot grid string. So again, this is another, we're running it and hoping it doesn't change. That's good. Okay. Now we want to implement support for the stringable raising trait. I don't know what that means. Let's see what that means. So we're looking at the Mojo programming language, if you're just arriving, which is, yes, hello in the chat if you fancy it. And all we're doing, what this is allowing us to do is to, what's it allowing us to do, Kevin? It's allowing us to have a single language. So it's a bit like Python. It's a lot like Python. It's based on top of Python, but it's 68,000 times faster, which is apparently a lot. So we're having worked through their tutorial and seeing what we think of it. So far, it looks pretty good. We're making John Conway's Game of Life, so we can kind of see the shape of this. When we run it, it turns out to be this. And we've got this struct thing that feels a bit like a class or a data class in Python, especially when you annotate it with this value decorator. It can take values and it can take methods. So it feels very sort of Python classy. So you can pass most Mojo types to the built-in string function to produce a string, but you'll get an error if you try to do it with your current implementation. So let's fix that. Oh, so this feels a lot like implementing the _stir method. It is just, okay, it is doing exactly that. So we're going to go back to our grid over here, and we're going to say stringable raising. Now, that's how in Python, that's how we subclass something. Is that the same thing that we're doing here? In this case, it requires a type to conform either to, so it's a trait, so we're sub-traiting almost. We're saying this is a trait that it's matching to. Interesting. So then we need to implement the stir method. And is that just us renaming? Yeah, that's just us renaming this grid stir. So we'll just rename this as dunder stir. And there's a red squiggly here because we're saying we're implementing this trait, but we're not following the contract. Once we do follow the contract, the red squiggly is gone. So we can go back to Mojo, and instead of print start.gridstir, we can just say print start. Oh, did I forget to save it? Is there a problem? Invalid call to print. Could not deduce. Oh, I have to turn it into a string. There we go. Okay. Again, it's another step where nothing's really changed, but we how we've done it has worked well. So implement methods to support indexing. Looking at the row implementation nodes that we use, row columns, retrieve value, would use to refer to a cell. This breaks fundamental calculation. We need to know the grid stores. Yeah, it's true. A cleaner approach is to provide a getter and setter to access values. We can simply define methods like get cell and set cell, but it's a good opportunity to show how we can define behavior built-in operators for custom Mojo types. Specifically, we'll implement and support indexing so that we can refer to a cell, row, column. It's useful in implementing. That looks fun. Alrighty. So we're going to create. So this doesn't have to happen because it's following some kind of trait. It's just happening anyway. So that's interesting. And def is 4 spaces in. So 1, 2, 3, 4. We'll say def get item, my row, which will be an int, call, which will be an int, and that's going to return presumably an int, which is the 1 or 0 about whether or not it's populated. And so we'll return self, dot data, row call. And set item is going to do the same thing. So return, why are you red squiggling? Is it spacing? So annoying. And why are you red squiggling now? Expression must be mutable in assignment. Ah, okay, so I need to declare that I'm going to change self, and I do that by using the mutable keyword before that. Okay. The implementation of get item is easy for the given values. Set item is similar to before. Just need to take the value, blah, blah, blah. Not ready to go. So that means now. So now we say if self row calls, we don't have to do dot data. So if self row call equals 1. Why are you red squiggling at me? What's the problem? Invalid call to get item. Oh, so it's self row comma call like this. Nice. Okay. And again, that'll hopefully run and nothing's fantastic. So I hadn't changed our program behavior, but it's still a good idea to run to make sure it does. Finish. Next thing we'll do is we'll define a static method to generate random grids. So far we've used a glider to build the basic functionality of our grid. So what's more interesting to start with our grid in a random state and see how it evolves over time. So we'll add a random struct to our random function to our so here it's going to be a static method, and we'll define random for rows and calls, which is going to return a list of lists of ints, I presume. Oh no, it's going to return an instance of this type of grid. Sorry, that's true. So we're going to import random. And I think that's using Python's random library. I don't know. I don't know if that's to get a random seed function. Why are you orphaned, decorator, not associated with declaration or a statement? Here you are, it's right beside. right beside there, indentation. Oh, I'm going to cry. And that's why. Is that why? Yeah. Okay. So let's get rid of that. So def random. Why are you shouting at me here? Expected end of function. Oh, I haven't returned anything. Okay. So that's good. So I'm randomly seeding. Chosen. And I'm going to create a new list for data. And then for row in range rows, and for call in range calls. Oh no, apparently I'm not doing that. For row, I'm going to create a row data, which is going to be a list of ints. Then for call and range calls, I'm going to append a random random underscore SI64, 0 or 1. I don't know the difference, but hopefully it'll tell me in a second. And then once I've done that, I will append the row to the data. And I'll finish off by returning an instance of the self with rows, calls, and grids. Now this got red squiggly. I presume it's because of spacing. Have you all got... Oh, so annoying. And last one. Okay, problems. Invalid call to append. Row.data.append. So this needs to be turned into an integer. This call doesn't actually get used, so I could just put this in underscore. This row doesn't get used, so I could put that as an underscore. Okay, cool. Okay. Fine. Okay, so that random is Mojo standard library random. Okay, so that's good. It uses pseudo random, so int, say seed based on the current time, so it's unique value every time. SI64 to the random insert from the minimum and maximum 0 to 1. It actually returns a value of type int64. So then we need to convert it to an int and then create a self. Okay, so now back over here, we'll now get rid of our glider to start off with. And we'll say start equals grid.random, and we'll say it's a random grid of 8 by 16. And when we run this now, we should see a random grid. And every time we run it, it's going to be different. Cool. Okay, looks good. Okay, so now we've got our grid, we want to get it to evolve and see what the next generation looks like. So we will create a method which we'll call evolve, which will take an instance of the self, or we'll take the self and return a new self. So we say next generation, and it will start off just being a list of lists of ints. And you're going to start it by spacing. It's definitely going to make me cry if people keep doing this. It should be, oh no. Actually, it might be okay in the context of this function. Is it? No. Yeah. Anyway. This is one of the reasons why I sometimes find myself actually using PyCharm, is because it don't have to deal with this. But yeah, for row in range, self.rows, we get our row data. So I'm going to pull up Vim list, which is going to be the current there. So we calculate the neighboring row indices. And remember there's wraparound as well. So we say row above is going to be row -1 mod self.rows. That's going to allow it to wrap around. And then row below is going to do row +1 mod self.rows. So again, this feels very There's nothing sort of new here. This is very Python-y. So if you're familiar with Python, then this will feel very, very familiar. So now we've got that. We'll say for call in range, self.calls. We'll do call left and call right, same thing, including wraparound. We'll get the number of neighbors. So number of neighbors, just going to add them all together. So there should be in 8 directions. So row above, call left, row. So we've got all 8 directions are being represented here. So we'll just grab those to get our number of neighbors. And just grab some more of those away. So if we just take those number spaces away, then we should be okay. So then our new state, so determine the new state of the cells. We're going to say, we'll start off as being dead. So if the new state is 0, I'll see how good this auto-completed code is. The right level? Yep. So new state is 0. And we'll say if self row call equals 1 and num neighbors equals 2 or 3, then, so if either of those, then the new state should be 1. So otherwise, if the row is 0 and the number of neighbors is 3, then it should be 1. Okay, that is true. That works well. I'm going to get rid of all this. So we're saying, just in case, again, we're Conway's game of life, we're saying that if the everything we're going to say, everything starts off dead and it's alive, if it was already alive and it's got 2 or 3 neighbors, and it becomes alive if it was dead and it has 3 neighbors. Okay, so that's what evolve is going to do. So then we can append the new state. We can say, hey, row.append new state. And that's happening inside here. And then one level up from that, we're saying next generation.append here. And then one level up from that, which is here, I think, will return self.row, self.columns, next generation. Any problems? One problem apparently. Oh no, no problems. Fantastic. Alrighty, we start off with an empty list, blah, 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 blah. That all seems fine. So now we can refactor our Mojo and we can say while true. So while true, print stir of grid. Then print a new line. We'll say if input enter Q break, otherwise otherwise what? Sizen. Otherwise grid equals grid.evolve, and that's actually going to be called, that's going to be our run display. Run display. Now interesting, it says owned grid, so it's going to get past grid and it's saying, look, I'm in control of this. The ownership is passing here, so it's going to be completely mutable. And we're going to say that that's going to be fine. So main then is going to start with a random grid of maybe 10 by 10, 16 by 16, however we want to do it. And then we'll run display and pass start in. And that should be it. Although, how does it manage scrolling? Interesting. Oh, so we can press return. As we press return, we're kind of seeing it evolve over time. So we kind of almost have a glider here, but this is going to die. And these two, both those are going to, we have a glider. So we should see is this one gradually coming down here. So over time it has a glider that's kind of coming down here. So that random grid ended up creating a glider. That's pretty cool. And then if we run it again, and just see how that evolves over time. We sometimes get little blinkers, sometimes get gliders, sometimes everything dies. Sometimes gliders bump into other gliders. Let's just see how this evolves. And then we get, sometimes you get into a static situation like this. So they're stuck there for time. That's pretty cool. So what else we got? Mojo lets you import Python modules, call Python function, interact with Python. So we're going to, in our terminal, we'll say magic add Python more than 3.11, but less than 3.13, and Pygame more than or equal to 2.61. but less than version 3. Okay, so it's gone off to do that work. We use Python codes, part of Mojo, building executable version, doesn't incorporate them. These runtime codes. The easy way to ensure this requirement is to deploy your executable in a virtual environment, such as one managed by Magic. Okay, so we'll see that in a second. So, up here then, we're going to say from Python, import Python, interesting. And in run display, we're going to say Pygame is Python dot import module called Pygame. We'll do Pygame dot init. Again, it's going to be spaces. Mojo doesn't put globally scoped variables. You must either import a Python module into each Mojo function that needs to use it, or else pass it as a wrap. There's an argument between functions. Okay. So our run display function is going to have the grid. It's going to have things like the window height. It's going to be an int, and it'll default to 600. So again, that feels very Python-y. A window width, which is an int, which is defaulting to 600. Background color, it's going to be a string and default to black. Cell color, which is going to be a string and default to green. Oops. And a pause, which will be float 64. I'll default to 0.1 to be equals. So we'll import it. We'll then create a window. Say window equals Pygame dot display dot set mode window width window height. We'll set a caption. So Pygame set a caption game of life. Stupid spaces. We'll set a cell height and a cell width. So our cell height will be our window height divided by the amount of rows, and our cell width will be our window width divided by that. We'll set our border size to be 1. Our fill color to be the cell color that we suggest up above. And our background color to be R. Cool. And we'll say while run, we'll set running equal to true. So again, that means it's going to infer that it's a Boolean. We'll say while running, we've got an event. Say event equals Pygame.event.pull. Say if event.type equals pygame.quit, then running equals false. Otherwise, if they press the escape key or the Q key, we also want to quit it. Okay, so let's just fix that. We want to fill the background color, so fill our window. And then we're going to loop over the rows. We'll fill in a rectangle of the right width and height. I have it ready to go. So let's do that. Then we will update the display. So display.flip is going to update the display. We'll pause for the number of seconds that we declared in our initialization function. And then I'll need to import time for that, I'm imagining. So import time. Then we'll evolve our grid. And we'll want to quit quiet and well. So if someone presses quit, we want to quit and close down and close the window. So everything else is largely, let's set this to 128 by 128 now. It's slightly more resolution in Pygame than we would in the terminal. So run, see if I can spot it appearing somewhere. I can't. Uh-oh. Did I forget to show it somewhere? Hello from Pygame community. That sounds good. Sounds like something's happening. Ah, here we go. Cool. Nice. So we have that evolving over time. Let's bring that in with us. Nope, doesn't want to. Let's come out. So what would be cool is, I would say, if lf event.key equals pygame.k space, then yeah, I want to basically re-randomize when I press the space key. And it may well be that that's what they were going to do next anyway, I don't know, but so startup time is a bit slower than I expected it to be. So we've got this random, because there's a 50% chance of something happening, then it starts off quite quickly. So every time I press space, it should start off random again. So that worked. I love this kind of, these flashing. So this is a static pattern we sometimes get. You can see it repeated here. So I press space again. Cool. That's feeling good. Where we get to, let's stop that. Oh, I can do that with the Q, can't I? Q. Nice. Alrighty. And we're done. Okay. So let's have a look at the code we wrote and see what we think about what's been going on. So this was us looking at Mojo and trying to work out what we thought about it. And all I did today was work through the tutorial. And yeah, so I quite like it. It feels very Python, feels very similar to Python. There's not a lot of like uniquely or anything that scary. Static method appears in Python. At value doesn't. Struct doesn't. But we can kind of see what they mean. We've got other things like class and things that are kind of there and doing the same things. That's awesome. Our life.mojo. We can import our structs and use them as our own types. And they're going to have those methods, so static methods are going to be available so we can use them. Grid.random is a static method that's there. And I can create new versions of them as well. So that's going to be, that's okay if I want to. So thoughts on what I'm going to do. So yeah, so I've been asked to think about creating a course on this. I guess what I would want to know now, I feel like the bits that are covered there are super helpful. I guess my next question would be, yeah, let's have a look at the change log. We're on version 24.6. That came out in the middle of December. If I look down this list, I can see 24.6. So December, September, 24, 24. Okay, that makes me feel slightly better. So they jumped from version 0.70 in January of last year to 24.1. And 24 is actually the year of release. Okay, that makes me feel slightly less scared. So there are actually 6 major releases, or 6 releases last year. It's more than that, but okay, that makes sense. I like it. How are we doing? Roadmap and sharp edges. They like to add more syntactic sugar. We're working on improved stuff, optional types as well. It doesn't support classes, but structs seem to do a lot of what's there. Not dynamic, more static classes. There's no lambdas. There's no list or dict comprehensions. So there are some things that are missing if you're just jumping straight from Python. But I'm interested. So alias is a word I haven't seen yet. We've got from's, structs we've seen, var. This is a different syntax. Fn is fn interchangeable with def. Because we've got def down here. That's interesting. Okay. So I think my next step with this is to, so if can I change this just to def? So let me run this and to create the Mandelbrot set, I'm hoping somewhere. Here, down here. It's trying to create the Mandelbrot set. So it's working on it. Oh, it's not actually going to show me it. Boo. That's annoying. Okay. Yeah. So I think I will dig into this a bit more. I might do another stream. I will get my Twitch and sorted and fit it and ready to go, and explore this a bit more. Think about what I might build with this next and explore that. But yeah. Thanks for being here. I hope you find it helpful. And yeah, hopefully see you again soon. See you later.